Here we're given a vector that has a magnitude of 25, and it has a direction angle of 115 degrees, and we are going to be trying to turn this into a component form. So what I want to do is just have a brief sketch of what's going on. And so we're just going to kind of do a little XY coordinate plane here. Very, very beautifully drawn. We know that 115 degrees is a little bit more than our 90 degrees here. So we're going to put it about there. And we're just going to make a note to ourselves, this is our 115 degrees. We have our theta measured from the positive x-axis counterclockwise, and the length of this vector is the 25 here. Now, we're not given units of measure, so we're not sure what they're measuring. It could be miles per hour, anything like that. But a lot of people will kind of slip up from this point on. They'll get caught up in doing something like this, and they'll say, look, here's my right triangle. They're not wrong, by the way. This is kind of where I would think of my right triangle to be. When you're in the second quadrant, you're going to have a Vx that is negative. So that's always worth noting early on because we're moving in the negative direction, while still retaining a positive Vy because we're moving upward in the positive direction. And some people will work within this right triangle. They'll subtract this 115 from 180, and they'll get this angle here, and they'll say, oh, well, now I can use right triangle trig to find the length of these sides. But when they do, they get positive values for these two numbers, when in fact the Vx is supposed to be negative. So for me, I prefer to stick with 115 degrees because I already know that there's a generic, nice, clean process we can use for each of our components, as long as we're given that initial angle that we need. So this is Vx. Just as a reminder, this is going to be the magnitude of our vector v, that's the 25, times cosine of our theta, which is the 115 degrees. So here, Vx is going to be 25 cosine of 115. And then my hope is it's pretty okay to switch over and just say that Vy then must be 25 sine of 115. I'm going to go and put my little approximate symbols here because we know these tend to work out in a way that's a little bit messier. You usually get decimal values for these, although sometimes you'll get lucky if you have really nice angles. So we're going to go and put 25 cosine of 115, and we're going to see about negative 10.6. And I'm going to cheat just a little bit and hit second enter here because this calculator, if you do that, you can get your previous entry in. I'm going to hit the sign button there instead to overwrite that. And we see about 22.7. So let me write that down real fast. We said negative 10.6. We said 22.7. And I do want to verify I am in degree mode. Okay, I just wanted to check that just before we moved on. And here we're going to see that with this method, with this setup where we use the original angle given, it already creates the proper direction for me. We see that our Vx ended up being negative. So I already feel pretty good about going in and writing this down. So negative 10.6, that's our x, so that's first. And then 22.7 should go second. That's going to be our component form here. That's what our little v equals. Maybe I should have made that note. And then here's where we would just want to go ahead and run the check through. So if you feel pretty confident about what just happened, you can go ahead and stop there. But just as our reminder, if we're not sure that we've done this correctly, we can check it in a couple of ways. The first way that we're going to do this is we're going to go in and take the square root of 10.6 squared plus 22.7 squared. This Pythagorean theorem, just to make sure that it's something close to 25. And we see, again, very similar to our last video, it's just a little bigger. So about 25.1. That's because we rounded these values off. We rounded them up, so this is rounded just a little bit heavy. That's good. We know that these values probably work out here. And then we could go in and try and figure out a few other things. So let's see, 180 minus 115, we mentioned this earlier. We see that this is our 65 degree angle in here. That would mean that Vy should be decently bigger than Vx in terms of just general magnitude. And we see that 22.7 is, in terms of magnitude, bigger than 10.6. So everything seems to be checking out really well here. I feel really confident in this answer, and there you have it.